All right, well, good morning, everyone, and welcome back to another exciting day in mathematics. Whoop, whoop. How's everybody doing? Good? Yes, Mr. Q. All right, good. Well, warm-up number 53 is on your screen. Number 1, read, simplify, and round your answer to the nearest 10th, square root of 23. Let's go. Number 2, it says graph f of x equals parentheses x plus 5 close parentheses squared minus 6. Number 3 says factor by grouping. Part A reads x squared plus 3x plus 18 plus 6x. Part B reads 10x squared plus 7x plus 1. Number 4 says divide the polynomial with synthetic division. Parentheses 7x cubed minus 6x plus 9, close parentheses, divided by, open parentheses, x plus 5, close parentheses. And number 5 says solve the system using substitution. And they give us a linear system, negative x plus 2y equals 2, and y equals x plus 3. Now, by now, numbers 1 through 4 should be a piece of cake. Number 5, I'm trying to retrieve some old knowledge they have in your long-term memory, because we're going to need it for the session that's coming up, not in the following one, but the one after that. We're going to get into systems, but with quadratics. Yeah, let's go. But I'm going to give you some practice first with simple stuff like that. And I'm taking you way back to when you were itty bitty 8th graders with me. Aww. Some of you were already big. So, but anywho, those of you that weren't with me, your teacher should have gone over those systems. And hopefully that refreshes your memory. All right, I'll give you guys some time for that. Then I'll go over some of those answers, and I'm going to go over number 4 and number 5. Well, I think I'll go over most of them just to make sure we got it. All right, I'll give you some time. Copy and go. All right, let's see what we got. Number 1. What'd you get for number 1? Avril.
I got 4.7.
4.7. Hands, have you got that? Close.
Oh, was it 4.8?
4.8. Hands, have you got that?
I knew it.
Close. Who said approximately 4.8? Oh my goodness. April's like, come on, Mr. Q. Well, you know, it's about like being correct with your mathematics. Okay. Here we go. So graph number 2. Look up. By now, this is where I need your noodle to be. Look up to the screen. Look up. Look at this function. What kind of function is it? Well, it's got a square there. That means it's a what? A quadratic. That's correct. So what is the parent function? The parent function goes through the point of origin, and it's a parabola. There it is. Okay. All right. So what transformation do they give us? Oh, they give us h, and they give us k. K is going down, and h is going to the left. Or now that we know h and k become our vertex, is that correct? So what is our vertex for the new transformation? -5, comma, -6. So I'm going to take this vertex and move it to what? -5, -6. So I go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. So our parabola should be somewhere down here. And notice that it didn't say make a table. And notice it didn't say do all this and that. This is where I need you guys to be a little bit more thinking outside the box. And by now, you should be more familiar with these kind of transformations. Yes? Yes, Mr. Q, we love these. All right, good. All right, let's move on. Number 3. Let's see, let me make some space here. All right, so let me go over number 3 just to make sure, because some of you just went straight at and getting to work. However, what is the first step before we start factoring? It needs to be in what? Standard form. That is correct. Is this in standard form? Let's see. Second degree, first degree, 0 degree, first degree. Nope. Let me rewrite that. X squared plus 3x plus 6x plus 18. Now I can group them. The first two terms, the last two terms, GCF is x, we're left with x plus 3, plus GCF for the last two terms is 6, we're left with x plus 3. My factors are x plus 3, x plus 6 factors. Some of you are like, Mr. Q, but I got something very similar. I know, but I need you to follow processes, please. Let's go to number 2. Once again, by grouping. Is it in standard form? Yes. Can I factor from there any GCF? No. So I have a leading coefficient of 10, multiply that times 1, so that's 10. And 7 down underneath. Factors of 10 that add up to 7, 5, and 2. So I'm going to rewrite this. 10x squared. Instead of 7x, I write 5x plus 2x. Bring down plus 1, the last term. Let's group the first two and the last two. First two, GCF is 5x, and I'm left with 2x plus 1. GCF for the last two is basically just 1. We're left with 2x plus 1. So my factors are 2x plus 1 and 5x plus 1. Man, I like these. Yeah. We good? Yeah? So far, so good? Now, are you guys, do you guys get it that a lot of the practice from the warm-up is helping us like throughout, just to refresh in our memory with some of the concepts, and also when we get to the other lessons, you have already some of the skills from what we've been practicing. So please, pretty please, if there's some of you, because I've been uploading, I don't know if you guys noticed, I've been uploading the asynchronous assignments, and I've been seeing some of your notes. Believe it or not, yes, I read hieroglyphics. I've been seeing some of your notes, and some of you are not doing the entire warm-ups, and some of you are not doing the entire lesson. So please, pretty please, you need to do each part of whatever I'm giving you, because it's integral part of your the entire course. Okay. All right. Let me go over number 4. Let me make some space here. All right. Step 1. Is it in standard form? Let's see. 3rd degree, 1st degree, 0 degree. Yes. Are there any powers missing? Yes, Mr. 2. Number 2. I'm going to box it to remember that. The second polynomial. 1st degree, 0 degree, nothing missing, standard form, yes. So I'm going to start my synthetic division using the divisor, and I'm going to use -5. Then I'm going to use coefficients and constants of the dividend. So I'm going to start with 7. What was the power missing? The second power. So I'm going to write a 0 for the second power. Then I write -6 for the first power, and then the constant. I bring down 7 and I start my multiplication. -5 times 7, that's -35. Combine, that leaves us -35. All right, let me multiply again. -5 times -35, that's 175. Combine 175 and -6, that's 169. Then we multiply -5 times 169. So that's, let's see, again, 7 times 5, that's 35, that's 350. 500, that's 850. Take away 5, 845, and it's a -845. Okay, combine, and that gives us -836. Now we have a leftover. You're like, oh, snap, Mr. Q. I know, right? So let's rewrite our quotient. Our quotient is 7x squared minus 35x plus 169. And then we write our leftover as a fraction. We're left with 836 over our original divisor, which was x plus 5. Woo, let's go. Love these, yeah? Piece of cake. All right. Let's go to the last one, number 5. Let's see, number 5. Make some space here. Okay, so here we go. It says solve the system by substitution. So to refresh your memory, a system of equations is when we have more than two or more equations, yes? And they become one component. So here we have 2 linear equations. So when we solve system by substitution, I said the most important thing, I'm going to take you back in time, is to solve one equation for one variable. One equation for one variable first. So do we have any of the equations already solved for one variable? Yes, the second one. Notice here, this is y equals to something. So why do we need it solved? Because now we can substitute into the second equation here. Instead of writing y, we're going to write what? X plus 3. You're like, oh, I remember now, Mr. Q. So I write the second equation, negative x plus 2, open parentheses, equals to 2. And instead of y, I'm going to write x plus 3. You're like, oh, snap, flashbacks, Mr. Q. Negative x plus 2x plus 6 equals to 2. Combine like terms right here. That leaves us with x plus 6 equals to 2. Solve for x minus 6 minus 6. So we're left with x equals negative 4. All right. Now, am I done? No. Remember, whenever we solve a system, we need to come up with a coordinate. And what is that coordinate? Where both graphs intersect. What is that coordinate? Where both graphs intersect. What is the coordinate? Where both graphs intersect. Tell your neighbor, whoever's there. Tell your dog. Or your bird, my bad. Alvaro's like, I have a bird, it's cute. All right, so we substitute x into the second equation. My other equation was y equals x plus 3. Y equals, and now x is what? Negative 4 plus 3. So y equals negative 1. So now that we have these values, our x is negative 4, our y is negative 1, and that's our solution. And once again, what does that solution mean? That's where both graphs what? Yes, intersect. Okay. I'm just giving you a heads up because we're going to get into systems with quadratics, and hopefully you understand what that coordinate or coordinates mean. You're like, oh, I see where you're going, Mr. Q. I know, right? All right. We good? Yeah? Yes, Mr. Q. All right. So our agenda for today, warm-up number 53, which is the one we just did right now. Today we're still focusing on parabolas. And home plate for tonight is 8 graphs of parabolas only. You see, every time I say only, it makes it seem like very little work, right? Am I right? Am I right? Yeah. Like you go to buy a TV and the salesman is all like, oh yeah, this is only $399,000. Okay. All right. Your asynchronous, did everybody copy that? Yes? Okay, asynchronous, here we go. Your synchronous code is 7C56S. 7C56S. And let me do a quick exercise with this because somehow, I don't know, I think people maybe misunderstood or just want to make sure we got it. It says, log in beginning with period number, then first name and last name. Okay, so let's say I'm Michael Jordan and I go to nearpod.com, type in that code, then it's gonna ask me to log in. Okay, period number, okay, 6, first name, Michael, last name, Jordan. Hey, that was easy. Let's go. Did everybody understand what I just did? Yes. Start with the number. Oh my goodness. As I'm going through reports, some of you are like, don't even write like the number. Some of you only write your first initial, then the last name. And it's like, are you serious? My goodness. I was about to slap my dog. But no, I'm not going to do that. It's not his fault. So please, pretty please. Also, just FYI, you know, and I don't think it was any of you, my student wouldn't do that, but somebody logged into Nearpod and they logged in with a obscene words, by the way. They're like, what? Yep, they wrote some obscene words, bad words. And I'm like, okay, why would they do that? You know, knowing that Mr. Q's a techie. You know what I'm saying? So guess what I did? I did some shuffling and buffling, and I found the IP address of that person. Let's go. Now, for those of you that don't know what that means, let me tell you. An IP address is a number that all electronics have. You're like, what do you mean, Mr. Q? Your computer, let's say you don't want to log into a website, but you want to send some something to, or you want to log into a game, or you want to do whatever you do. The way people can track back any activity to a certain electronic device is known as an IP address. You're like, what? Oh, yes. So for those of you messing around, I mean, not you guys, but some people that are messing around with sending stuff out electronically, guess what? You have a record with your IP address. So I have the IP address. I just need to give myself some time so that I can contact the techs and they can figure out like addresses and stuff like that. So please, pretty please, anytime guys, when you're logging on online or you're doing anything with electronic devices, remember, you are being tracked. Everything's being recorded, everything. And let me spell that out. Everything. Everything. Yeah. Everything. Please, pretty please stop messing around.
Yes, Mr. Q.
Especially those of you that are gaming and messing around with all that stuff and on the black web or whatever it is you do. Stop it, guys. I'm telling you, they're keeping track of all that. I'm telling you, you're like, Mr. Q, you know about that? Oh, no. All right, your previous home play, 8 problems, turn that into Canvas. I'll give you some time for that. If you already did, go and get a Cornell note ready. You need a Freire model. You need at least, let's see, 1, 2, let's do 2. 2 coordinate planes from -10 to 10. Freire model, 2 coordinate planes from -10 to 10. Get that ready. I'll give you guys some time for that. All right, and in the meantime, while you do that, I'm gonna leave the home plate posted. Those of you that already turned in your stuff. This is a home plate for tonight, but like I said, you can get this from your asynchronous. You don't have to copy it all right now, okay? All right, I'll give you some time for that. All right. So once again, you should have turned in your home play. And by the way, I upload the available assignment usually like around 7:45 in the morning. So you have all morning to submit your stuff till 11:59. So yeah, this home play, if you notice this new home play right here, it says write the equation of parabola and graph. Number 1, focus -4, -5, directrix y equals 1. Number 2, focus 6, -4, directrix y equals -10. Number 3, focus 0, 7, directrix y equals 3. Number 4, focus 5, 1, directrix y equals -3. Number 5, focus -1, -1, directrix x equals 5. Number 6, focus 5, -1, directrix x equals -3. Number 7, -2, 0, focus -2, 0, directrix x equals 4. And number 8, focus -4, -5, directrix x equals -8. And if you notice, all of them look almost exactly the same as what we did last time. Yes? Yes, Mr. Q? Yeah, but today I'm adding one more step. You're like, bam! I know, right? Oh, yeah. All right, here we go. Our objective for today, I can write and graph a quadratic equation of a parabola. I can write and graph a quadratic equation of a parabola. Once again, what concept are we still on? Yeah, parabola. And what have we been doing? Writing and graphing quadratic equations, okay? So in your Freire model, your own words, what is the definition of a parabola? Example, non-example, and a hashtag. I'll give you a minute for that. Copy that and go. All right, so you should have gotten a definition, an example, non-example, and a hashtag on your own. From there, Quick recap, we started with, I took you back to the original standard form equation of parabola. From there, I gave you guys the deriving the quadratic formula, and we came up with a vertical equation, which was x squared equals 4py. And then we said that we no longer just have a vertical parabola, we also have a horizontal. Vertical, it opens either up or down. Horizontal opens either to the right or to the left, and always towards the focus, yes? And we said we're gonna focus first on these two, x squared equals 4py for the vertical, y squared equals 4px for the horizontal. We did some examples of each, and then from there, we came to the conclusion that those two always cross through the point of origin, which was 0, 0 for the vertex. Your vertex was always at 0, 0. And just to clarify, the vertex of a parabola, it's either the lowest point or the highest point. Once again, what is the vertex? The lowest point or the highest point, okay? Wake up, people. Some of you are falling asleep. From there, we added more to those, and then we saw that for the vertical, we had, instead of just x squared, we had x minus h squared equals 4py minus k. For the horizontal is y minus k squared equals 4p open parenthesis x minus h. And what is the obvious thing that we added to both? The vertex, which now would be h and k. And we did some practice problems right away. We went into example 1 Q, 1 super Q, 1 mega Q, and then we moved on to example 2. But before we go again to example 2 and add to that, let's do one more. Ready? Copy this one. Example 1 Shazam Q. Write that down. It says, example 1 Shazam Q. Write and graph the equation of parabola with focus -5, -6, and directrix y equals -2. Copy that. 20 seconds, and by now you should have already had your coordinate plane, right? I give you plenty of time at the beginning. Once again, instructions, write and graph the equation of the parabola, focus -5, -6, directrix y equals -2. And by now, you should know how to do this one on your own. However, for the sake of those of you that are still, you know, maybe you need extra practice, here we go. So let's do this one together. So you got plenty of practice over the weekend with these, but here goes once more. What is the first thing we do? We look at the directrix. The directrix is y equals -2. -2's down here, and I have a straight line going through the directrix, which is y equals -2, and there it is. Okay. From there, what else do they give us? They give us a focus at -5, -6. -5 of x, -6 of y is down here. Okay. Now look at it, guys. Look at the directrix. Look at the focus. So if I was to ask you a question, in which direction is the parabola going to open towards? Which direction is the parabola going to open towards? What do you think, Manny? Where is it going to open towards?
To the focus.
To the focus. And where's the focus? It's downward. That means it's going to open downward. Yes. So if that's true, it's a vertical parabola. So what equation are we going to use? We're going to use parentheses x minus h squared equals 4p parentheses y minus k. K? What it did there. All right, so let's see. What is it that we need to graph a parabola? So we need, of course, a focus, we need a directrix point, and we need a vertex. So let me list what they give us. They give us up here, we give us a focus of -5, -6. What else do we need? We need a vertex, and we need a directrix point. Let me start right there. So if I go to my focus, and I go straight up to the directrix line, and I place my point there, there should be a point there on the directrix. What is that coordinate? -5, -2. Let me write that in here, -5, -2. Well, with that said, now we can picture our parabola going through those 2 points equidistant. So that means there's a vertex in between those 2 points. I'm going to place it right there and look at it. Since all 3 of them are aligned, what do they all have in common? What do they all have in common? They have the x value of -5. So far, so good? Yes. All right. So then from there, I said, let's take roll call. What else do I need for me to rewrite my equation? I need an h value. It's right here on the vertex. It's the first value that I have there. I need a k. Do we have a k value here? No, that means I need to figure out k. How can I find k? What do I compute, Alvaro, to find k?
I forgot the equation.
Okay, so it's take the y value of the focus and we subtract the value of p. Thank you. So in order for me, I have the y value of the focus up here, but what do I need to compute? P. So I'm going to write here p. Now hopefully you remember how to compute p. Yes, Mr. Q, you take the y value of the focus, -6. We're going to subtract the y value of the directrix point, divide by 2. Now make sure whenever you're doing substitution, don't forget to put this negative first, or the subtraction first between these two numbers, because if you don't, you're going to make a mistake with that computation. So here we have negative times a negative. This becomes a positive. So this is -6 plus 2, that's -4, divided by 2, that's -2. That's P. All right, now that we have P, we can compute our K. All right, so what is the y value of the focus? It's -6. Then I'm going to subtract what value? P. What is P? -2. So negative times a negative right here becomes a positive. So -6 plus 2, that's -4. And that's my K, -4. All right. So my vertex is at -5, -4. Let's double check to make sure if it is there. -5, -4. Yes, it's right there. So now that we have those values, let's substitute our values into our equation. X minus empty space squared equals 4, parentheses for P, parentheses Y minus empty space. Okay. So what is H? -5. What is K? -4. And what is P? -2. Let's simplify this. Parentheses, X, negative times a negative is a +5 squared, equals 4 times -2, that's -8. Parentheses, Y, negative times a negative is a +4. That's our equation. Now don't graph your parabola just yet. Okay, so here we go. Today we're adding one more step. Okay, here it goes. Focus or you're gonna miss this part. So for today, I do want, pay attention to this part, I want some points for my parabola. Let me repeat that again. Today, I do want some points for my parabola other than the vertex. Okay? So in order to get some points, we would usually use a table. Is that correct? Yes, Mr. Q, but today I'm not going to have you do the table. What I want you to do is pick an X value, do the work so you can find your Y, write your coordinate, and then we're going to reflect that to the other side. So here we go. Look up to the screen, writing utensils down. Here's my vertex. So what does that mean, Mr. Q? That when we start graphing our parabola, it's going to graph this way and it's going to reflect to the other side or vice versa. Okay, so what does that mean? In order for me to get some points on this side or that side, I need to start with an X value in order to get a Y value. Is that correct? Yes. So my question would be, I can choose any number either from the left side of the vertex or the right side of the vertex. Everybody following so far? Okay, so check this out. So if I was to pick a number from the left side, I would go with either -6, -7, -8, -9, and so on and so forth. Or from the right side, I would use either -4, -3, -2, -1, or 0. Which number would you like to use and which one seems the easiest? What do you think? Think about it first. Alexandra, which number do you want to use?
-6.
-6, okay. She's going with the number right next to. Okay. Now here we go. So what you're going to do tonight, you're going to take the equation you came up with. Here it is. X plus 5 squared equals -8, parentheses, y plus 4. And we're going to substitute -6 into here for the x, because that's the x value, yes? So check this out. I'm going to write -6. And I'm going to bring down the plus 5 squared equals -8, parentheses, y plus 4. All right. So copy this and let's do this part together. I'll give you a couple seconds, 10 seconds to copy that, and then we'll do the computation together. And basically, this just extra step is so that we just are pretty as accurate as we can when we're sketching our parabola, okay? All right, so here we go. So what is -6 plus 5? That's -1 squared equals -8, parentheses, y plus 4. What is -1 squared? That's 1 equals -8, parentheses, y plus 4. All right, now we need to solve for y, which means we need to get rid of this -8. What is the -8 doing? It's multiplying. So what is the inverse? Divide by -8, divide by -8. That leaves us -1/8 equals y plus 4. And our last step is -4 minus 4. So that leaves us with -4 and 1/8, 1/8 equals to y. So what is my coordinate when x is -6? When x is -6, my y is -4 and 1/8. So -6, -4 and 1/8, a little bit more right there. Okay, there it is. Now look up to the screen. What do we know about parabolas? That this point is going to reflect to the other side, is that correct? Yes, Mr. Q. So who can give me the coordinate of the point that's going to reflect to the other side? Who's got it? One at a time, slow down. Elizabeth, what's our coordinate for the other side if we're reflecting that?
Mr. Q, can I say it?
Okay, go.
-4 and -4 and 1/8.
That is correct. -4, -4 and 1/8. Let's see. -4, -4 and 1/8. And there's our parabola. Now, how did we know that it was going to give us the same number for the y value? Because it's reflecting to this side over here. What's the only thing that changed? The x. Look up. The -6 is only one step away from -5, and -4 is only one step away from -5. That's why we only went -4, -1/8. Now, could Alexandra said instead of -6, could she have chosen, let's say, 0? Could we have used 0 and substitute and did the work? Yes. Could we have chosen -1 instead of -6? Yes. Could we have chosen negative? Yes. Any number on the right of that vertex for the x values or on the left, you can use. And once you get that, you just reflect that to the other side. Okay? All right. So with that said, how comfortable do you guys feel so far with this added step? Let's see, from 1 to 5, your polls on the screen. 5s, 5, 5, 5, 5, 4s, 5, 4s, 5, 4, 5, 4s. Couple 3s, 5 4s, 5 4s. Yeah. And notice that's why last time I gave you guys plenty of practice for the process of getting your equation, and now it's just adding a value for x. Okay, so Let's move on. So then from there we did example 2 to Q to super Q. Let's do this one. Example 2 Shazam Q. Or wait, did we do this one? Example 2 mega Q last time? Check your notes.
We didn't.
We didn't? Okay, then copy that. Example 2 mega Q reads, write and graph the equation of the parabola, focus -2, -8. I'm sorry, -4, -2, and directrix x equals -8. Once again, focus -4, -2, directrix x equals -8. All right. So let's do this one together. Here we go. And yes, we're going to do the whole thing. We're going to get our equation, and then we're going to graph it. But before we graph the parabola, we need at least to get 2 more points aside from the vertex. So our directrix is x equals -8, which is over here. And a straight line is going through there. Man, I love technology, right? I don't have to be erasing or anything like that. Man. The only thing from time to time, it makes my writing look pixelated, but that's all right. Focus, -4, -2, -4, -2. All right, by looking at it, which direction is this going to open towards? Which direction is this going to open towards? What do you think, Gamer Boy Enrique? Which direction is the parabola opening towards?
To the right?
To the right, that is correct. So that means this is a horizontal parabola. So we're going to use what equation? Y minus k squared equals 4p parentheses x minus h. So far so good, yeah? Some of you are already way ahead of me. My bad. So well, let's see what they give us. They give us the focus, -4, -2. We need a vertex, of course. We need a directrix point, which means a point that's on the directrix line, aligned to the focus. Let's start there. So here's my focus. I go all the way straight to the directrix. And the point on the directrix is at -8, -2, -8, -2. Now, can you picture the focus, the vertex between those 2 points? Yes, there. So what do they have in common? If you align them, look, follow all the alignment. This time they have in common y is -2. Okay, let's take roll call. What do we need to substitute in here? We need a k. Do we have that? Yes, there it is. What else do we need? An h. Do we have that? No. Okay. So that means we need to find h. How do we find h? How do we compute h? What's our formula? Avery.
Wait, I don't know the thing for it, but you take the X for the focus
Yeah, let's go.
and the X for the directrix.
Close. X for the focus minus P. Yes, very close. So that is true. So that means we need to compute P. What is P? Well, Avery was saying you take the X of the focus, -4, minus the X of the directrix point, -8. Subtract those and divide by 2. Here we have negative times the negative is a positive. So -4 plus 8, that's 4. Divided by 2, that's 2. All right. Now we can find our H. And let's see, what is our x value for the focus? The x value for the focus is -4 minus, what's P? P is 2. P is 2, Got that? Gamer boy Enrique, you hear me? All right. -4, -2 is -6. Let's write that in here. And now we have a vertex. Let's see if our vertex is at -6, -2. -6, -2, yep, there it is. All right, substitute our values. Parentheses y minus empty space squared equals 4, parentheses for p, parentheses x minus empty space for h. Now, what did I tell you last time? That be careful with these when you do substitution, because look, some of you want to go faster than your brain, and some of you start substituting. Some of you write -6 right here, and that is incorrect. -6 corresponds to the h, which goes over here, -6. -2 is our k, which goes right here, -2, and p is 2. So to simplify this, y plus 2 squared equals 8, parentheses, x plus 6. All right. That's our equation. But now we need to compute a point for this one. So look up. Look at all these points are aligned. Now we need a point either on either side of the vertex. So which value am I going to use now? No longer the x. This time I'm going to use what? Y values. So which value do you want me to use? I can go either upward from the vertex or downward. Look at them. Upward or downward, which would be an easy number to substitute in there. What do you think, Avro? Which would be an easy number to substitute? Above -2 or below -2? Give me a number.
-4.
-4, okay. So y plus 2 squared equals 8, parentheses x plus 6. So Avro says, let's substitute -4. So I'm going to take -4 of y and substitute it right here, -4. Okay. So let's see, -4 plus 2, that's -2 squared equals 8, parentheses x plus 6. -2 squared is 4 equals 8, parentheses x plus 6. Solve for x, so we divide by 8 both sides. That leaves us with 1/2 equals x plus 6. To solve for x, what do? -6 minus 6. So that leaves us with x equals, what is -6 plus 1/2? -6 plus 1/2 is -6 plus 1/2. -6 plus 1/2 is
5.5.
5.5. Very close.
Negative.
-5.5, yes. So my coordinate that I need is -5 and 1/2, comma. And what number did we substitute for y? -4. So let me plot that point. -5 and 1/2, which is right there. -4, which is down here. There it is. All right. Who can give me the point reflected to the other side? What coordinate will I need for the other side? So that one was that one. I need 1 point on this side of the vertex, which would be what? Let's see, Sophia, what do you think?
Would it be 0?
Okay, so let me start graphing the parabola. Here's my vertex, and it's going to go towards this side. And we need another going to the other side, right? So what do we know about parabolas? That from the vertex to this side, this point should reflect to the other side. So what do you think our point coordinate would be for the other side? What do you think, Bree?
0, no. -5.5, 0.
-5.5 and 0. Yes, and Sophia, you are almost there. I wanted to hear first the coordinate, which is -5.5, because remember, this is what they have in common. Notice here, they're aligned to -5.5, and we're at 0, which is right there. So that's going to reflect to that side. Woo, let's go. All right, one more time. Let's see, how comfortable do you feel with, now that we saw both, the vertical and the horizontal? 4 5s, 4 5s, 4 5s. All right. All right, so what is the only thing that we, so basically our objective said to write and graph equations for parabolas. Have we been doing that? Yes. But what did we add today? Just picking one point, computing that into the equation, and then make sure you reflect that point to the other side, okay? All right, guys, well, that's our session for today. Once again, make sure you stay on top of your work, stay focused, do your asynchronous assignments, and like I mentioned before, the asynchronous code is for you to submit your notes, but also include a couple more slides for you to do the extra practice on your own, okay? So make sure you stay on top of that. Once again, we're moving on to the next portion when we meet again. So other than that, I mean, tutoring after lunch today is, except for today, we already did the practice last week for this. Today I'm gonna be, have some meetings with some parents in the afternoon. I'm gonna be making phone calls for those of you that are needing that extra call from Mr. Q at home. Let's go. So have a good one, guys. Enjoy your home play, and I'll see you guys next time. Peace. Bye.
Peace.
Peace.